The next topic is transfer function. Transfer function is the ratio of Laplace transform of the output to the Laplace transform of the input. In this, consider all initial conditions to 0. Transfer function, in this R of t is the input and the system is g of t and the output is c of t. The transfer function is given by g of t equal to c of t divided by r of t. In term of Laplace transform, g of s equal to Laplace c of t divided by Laplace r of t at initial condition is 0. The transfer function g of s of the plant is given as g of s equal to y of s divided by u of s, where u of s is the input and y of s is the output. For example, determine V out of S divided by V input of S of the following circuit. Here we can write V input of t equal to Ra of t plus 1 by C integral of I of t dt and V out of t equal to Ra of t. The Laplace transform of Vi of t is Ra of S plus 1 by Cs I of S and the V out of S equal to Ra of S. Then V out of S divided by V input of S equal to R divided by R plus 1 by Cs. V output of S divided by V input of S is known as the transfer function. Determine V output of S divided by V input of S for the following circuit. Here V input of t equal to R1 I of t plus R2 I of t plus 1 by C integral of I of t dt and V output of t equal to R2 I of t plus 1 by C integral of I of t dt, and the Laplace transform is given by V output of S divided by V input of S equal to R2 of R2 plus 1 by Cs divided by R1 plus R2 plus 1 by Cs. Using Laplace transform, we can convert many common functions into algebraic function of complex variable S. For example, sin omega of t equal to omega divided by s square plus omega square, Laplace e power minus at equal to 1 by s plus a, where s is a complex variable and is given as s equal to del plus j omega. Not only common functions can be converted into simple algebraic expressions, but calculus operations can also be converted into algebraic expressions. The example is shown here. In general, Laplace of d power n x of t divided by dt power n equal to s power n x of s minus summation k equal to 1 to n s power n minus k x power k minus 1 into 0. Laplace transform of integrals are Laplace integral of x of t dt equal to 1 by s x of s. The time domain integral becomes division by s in frequency domain. Consider the following ordinary differential equation where y of t is input of the system and x of t is the output. A into d square x of t divided by dt square equal to c dy of t by dt minus b dx of t divided by dt, or it can be written as a x double dash of t equal to c y dash of t minus b x dash of t. Taking the Laplace transform on either sides, a into s square x of s minus sx of 0 minus x dash of 0 equal to c into sy of s minus y of 0 minus b into sx of s minus x of 0. Considering initial conditions to 0 in order to find the transfer function of the system, a s square x of s equal to cs y of s minus bs x of s. Rearranging the above equation, we can get x of s divided by y of s equal to cs divided by as square plus bs, which is equal to c divided by as plus b. In general, a naught for ny plus a1 of y n minus y 1 up to a n y equal to b naught of x power m plus b1 of x power m minus 1 plus up to bm of x, where x is the input of the system and y is the output of the system. The transfer function is given by g of s. When order of the denominator polynomial is greater than the numerator polynomial, the transfer function is said to be proper, otherwise improper. Applications of transfer function. Transfer function can be used to check the stability of the system, time domain and frequency domain characteristics of the system, response of the system for any given input. The stability of control system is roots of denominator polynomial of a transfer function are called poles, and the roots of numerator polynomials of a transfer function are called zeros. The assessment system. Assessment question is which is a part of control system. Thank you.